Procedure 1 says put 50 milliliters of tap water in a 150 milliliter beaker. So get your water from the tap. If you're a little bit short of 50 milliliters, you can use the distilled water, but don't waste it. Your instructions say use the 150 milliliter beaker. That's the smallest one you have, not these larger ones. Take your accurately measured 50 milliliters and put it in the beaker. Don't trust the lines on the beaker. They're not accurate. Step 2 says put your Pasco temperature sensor in the water to measure the temperature. This is before the microwave. So if I put the probe in the beaker, I'll be able to read the temperature right here. This is before microwaving. So I'll give it time so it stabilizes. Looks like it's 20.8 degrees Celsius. We'll have at least 4 microwave ovens, so just use the one that's closest to you. When it says microwave for a minute, I'm hoping you can figure out how to do that. After microwaving, it says put the temperature sensor in the hot water and then wait 10 seconds to allow the thermometer to equilibrate. Let me show you what that means. Initially the thermometer is cold, and it says so right here. If I put it in, it's not going to instantly read the temperature. It takes a while for it to warm up. So I'm giving it 10 seconds, and then the temperature of the thermometer will be the same as the temperature of its surroundings. That's what it means to equilibrate. Once it's equilibrated, 10 seconds, then press this green button here, and it will start graphing your data. And you also have this table so you can see the complete history of this experiment. So your goal is to gather the temperature after 120 seconds. The table will allow you to do that precisely. You can say stop, boop, and then you can look here for what was the temperature after 120 seconds, and it will tell you. I'm hoping you realize the slope of this graph is a rate of cooling. Temperature's dropping as time progresses. You have a nice table. The labels are already there. You just have to figure out what goes in each box. Your first experiment is scripted as a glass beaker. This is a new concept for you, joules, but I have given you a handout at your table that will allow you to calculate that. Second experiment, I'm asking you to use a metal cup instead of a glass beaker. You can predict, will that hold the heat in better or worse than the glass beaker. When you do the metal cup experiment, you can't microwave the metal cup. So microwave your water in the beaker, same as before, but then transfer, equilibrate, 10 seconds, and then start your data collection. While you're collecting this data, you'll want to compare it to the old. So up here, run 1 was my previous data, and if I check the box, when I check the box, then you can compare the previous data to this data. Once you've completed the glass beaker and the metal cup, then it says you should now try experiments of your own design to see what affects the rate of heat loss. On the table you have 3 more blank spaces where you can collect some interesting data. So your table will have a variety of materials that you can experiment with. You can engineer it to try to say, I'll keep all the heat in and see which methods work best. Or I'll try to get the heat to come out really fast and engineer ways to do that as well.